Alright, so let's finish off graphing here. So here we have, we already labeled our hole there, and we have our asymptote there. And so now let's keep going here. We have, let's go with 1 and negative 0.25. So it's going to be pretty close to that axis there. Maybe right about there. Then we're at 2 and 1/3, so maybe right about there. And this will probably make sense because if you guys remember with reciprocal functions, it'll approach that horizontal asymptote, but it'll never cross it. Our next one there is at 4 and negative 1. Then we have an asymptote at 5. At 6, we are at positive 1. And we didn't go any further than that, which is fine, because if you guys remember, if you guys did this last year, in Pre-Calc 20, we did a lazy man's way of graphing. So what you would do is, when we have these kinds of points, we just need our invariant points. And so here our invariant point is when y is equal to 1. So this value here is going to approach this vertical asymptote there, but it will never touch it. And same with this point here, it will approach that x-axis, but it will never actually cross it. So it's your lazy man graphing 101. Alright, and then you can do the same here. So start at your hole there, make sure it's an open hole, and it will approach that x-axis, but will never actually ever cross it. And we'll do the same here. It'll pass through that. So start from the hole, it'll pass through negative 1, and it'll continue and get really close to that vertical asymptote, but it'll never actually cross it. Then let's label this one. It's a little bit harder to label, but we'll throw that one over here. So we'll do g of x here. Sorry, that should be h of x. My apologies there. So h of x. Okay. So now let's move on to C. So I'm going to actually erase all of our written information. So I'll just leave the graph up, and we'll talk about the domain and the range of h in just a second. Alright, so now let's talk about the domain and the range of h of x there. And so the domain for h of x, so that would be d dot dot parentheses, and would be x such that x. And remember, so we can talk about what x can be. So x cannot be equal to 3 and 5. Remember, 3 was where our hole was, 5 was our asymptote, and it can be any other value there. So we can say that x is also an element of all real numbers. So it can be anything except for 3 and 5, and it can be anywhere in between, either above, below, it doesn't matter if it's decimals, as long as it's not exactly 3 and as long as it's not exactly 5. And now let's talk about our range there. And the range there, so we have parentheses, y such that y, and ask yourself, can y be anything? So this will be even going back to your previous unit. You know what, there's that horizontal asymptote at y is equal to 0. So that means that y here cannot be equal to 0, but it can be anything else. So we'll say that y is an element of all real numbers. Alright, and so that's the gist of it for our domain and range. We worked with that for a really long time, so hopefully we should be solid on our domain and range. So if you want a clearer explanation, which I'm not sure if I can give a better explanation than that, but definitely come see me. We can discuss it. Maybe we can even look at some more examples, but if you need any more help, then just let me know. Alright? So moving on to example number 3 here. So in this one here, we have an electronics store is doing a one-day promotion. Every hour starting at 9 a.m., the price of a 3D television is reduced by 5%. The price P of the television at T hours after 8 a.m. can be modeled by the function P at T is equal to 1020 subtract 51T. The number N of televisions sold at time T can be modeled by the function N at T is equal to 6T. So write an expression for the revenue R for television sold in T hours after 8 a.m. So for this one, to look at revenue, we're going to have R at T. That is going to be equal to the price of your television, multiplying that with the number of televisions. So that's going to be price times the number. So that'll be P at T times N of T. So then we'll just substitute, it was wonderful enough to give us those functions there, so let's just substitute that in. So we have RT is equal to, and P of T was equal to 1020 subtract 51T, times that by N of T, which was 6T. Then we can distribute there, so we have R of T there is equal to, that'd be 1020 times it by 6, so that would be 6,120 T, subtract 51 times 6 is 306, T times T is T squared. So this here is our expression for revenue, R, for television sold in T hours after 8 a.m. And so for part B here, we need to find out the revenue from 3D televisions, or from those sales at 12 p.m. So what is time T? So that we're dealing with in hours. So from 8 a.m. to 12 p.m., that's from 8 till noon, that is equal to 4 hours there. So after T is equal to 4 hours, we're going to substitute that into the equation. We're going to find out what R of T is. So here we're at revenue, and we're dealing with T is equal to 4. So we're going to substitute 4 in there, so we have 6,120 times that by 4, subtract 306 times that by 4 squared. You guys can put this either all into your calculators. I can do this into a couple of steps here. Here we have R at 4 is equal to 6,120 times 4 is 24,480. Subtract 306 times that by 4 squared, which is 16. That there is equal to 4,896. Subtracting those two numbers there, we have R at 4 is equal to 19,584. So writing this into a sentence there, so our revenue there was $19,584 from the sales of 3D televisions at 12 p.m. So we'll say that, so the revenue from 3D, we can say TV sales at 12 p.m., or we can even say noon there, will be, that'll be $19,584. All right, so just remember there, so your revenue is equal to your price times the number of TVs sold, and there we were given two separate functions, and we multiplied them together to find our revenue function. Then we just, for part B there, we substituted into our equation and solved for our revenue. Okay, so you guys can get started on your homework. If you guys have any more questions, definitely let me know. But here's your homework, so you guys can get started on that.